Hi everyone, Jack from Maths Forge here. In today's lesson, we're going to be subtracting fractions with a different denominator. So it works in the same way as adding fractions with a different denominator. The first thing you're going to want to do is to find a common denominator. So the two bottom numbers must be the same. And if you're really good at your times tables, this helps you figure out which numbers to look for. In this case, I know I can get this 2 to become an 8, so therefore it's the same as this 8 here, if I multiply it by 4. So I'm just going to times the left-hand fraction, bottom and top, by 4. And remember, if you multiply 4 to the bottom, you have to do it to the top in order to keep the fraction equivalent. And so by introducing this times 4, I now have on the left-hand fraction 4 over 8. And on the right-hand fraction, it stays the same because we haven't touched it. And now we have two fractions with a common denominator, 8. So we can just go ahead and subtract them. 4 minus 1 is 3 over the same denominator, which is 8. And if we check our answer, there we go. Now let's take a look at the 2 stars. In this case, I'm going to need to manipulate both of the fractions to find the common denominator. You see, I can't multiply the 3 by anything to get it to be an 11. So I'm going to have to find a number that both of them go into. Well, there's actually a quicker method to all of this. So if you take the denominator of the right-hand fraction, this 11 here, and multiply it to the top and bottom of the left-hand fraction, like this. So that's where I'm getting the 11 from, the other denominator. And you do the same for the right-hand fraction, but you take the left-hand denominator, so this 3 here, and times it to top and bottom. Now let's execute the calculations and see what we have. 11 times 1 is 11. 11 times 3 is 33. Minus 3 times 3, which is 9. 11 times 3, which is 33. So we have now managed to get a common denominator, which means all we have to do is subtract the numerators. 11 minus 9 is 2 over the same denominator, which is 33. And we can't simplify this any further, so this should be our answer. Let's check. There it is. Now let's move on to a 3-star question. So in the 3-star questions, we are subtracting mixed numbers from each other. So that's a whole number and a fraction. So the best way to do this, in my opinion, is to convert them to improper fractions. So to take the mixed numbers and convert them to improper fractions. So we're going to do 6, the whole number, times the denominator, 7, which is 42. And then we add this to the numerator here, 2. So 6 times 7, which is 42, added to 2 is going to give us 44. Over the original denominator, which is 7. And we're going to do the same for the right-hand fraction. 4 times 2, which is 8. And we're going to add this to 1, which gives us 9. And this is going to be over the original denominator of 2. Now we have to find the common denominator as we did for the 1 and 2-star questions. So I'm going to take my right-hand denominator, 2, and I'm going to multiply it to the top and bottom of the left-hand fraction. And I'm going to do the same with the 7. I'm going to multiply it to the top and bottom of the right-hand fraction. And executing this calculation, we're going to get the following. 2 times 44 is 88 over 2 times 7, which is 14, minus 9 times 7, which is 63, over 2 times 7, which is 14. And as you can see, we have a common denominator of 14, so we can just go ahead and do the subtraction for the numerators. 88 minus 63 will give us 25 over 14. And now we have to take this improper fraction and simplify it into a mixed number. So 14 goes into 25 once with a remainder of 11. If you think about it, if you go up in your 14 times tables, 14, and if you do another one, 28, you'll pass 25. So 14 only goes into 25 once with a remainder of 11 because you need to add 11 onto the first 14 to get to 25. So remainder 11 over the original 14. And we can't simplify this 11 over 14, but if you could simplify this fraction, I strongly suggest you do so. Check the answer. There it is. And that's it for subtracting fractions with different denominators. It's very similar to adding fractions with different denominators.